Today's problem, count numbers containing specific digits. Difficulty, medium. You are given an integer n representing the number of digits in a number and an array containing digits from 0 to 9. You have to count how many n-digit positive integers can be formed such that at least one digit from the array appears in the number. Well, the first one's a little bit too simple. Let's look at the second one. We have n is 2, so we need two-digit numbers, and we have the numbers 3 and 5. So we have to create as many two-digit numbers as possible that contain at least 1, 3, or 5. And it turned out there are 34 of those. Now the constraints are that n can be between 1 and 9, that the size of the array can be between 1 and 10, and the digits in the array can be between 0 and 9. Okay, now I don't really know how to put together a formula for, solve this directly. Like, let's say a formula on this example, the second example, to compute how many two-digit numbers can we make, each one containing at least 1, 3, or 5. But what I can do, I can tell you how many numbers we can make. I can tell you how many two-digit numbers we can make with no restrictions, with no conditions. That would be, for the first digit, you would have 10 choices, and for the high-order digit, you would have 9 choices. Only 9 because we don't want leading zeros. So 90 numbers altogether. And I can do this for n equals whatever. If n were 3, then the number of numbers we could make with no restrictions would be 10 times 10 times 9. In other words, 10 to the power of n minus 1 times 9. Now I can also tell you, in this example, how many invalid numbers we can make. That is, numbers that do not contain a 3 or a 5. I can do that by counting the number of digits in the array. In this case, it's 2, and subtracting it from 10, so that's 8. So if we wanted to make invalid numbers, we would have 8 choices for the first position and 7 choices for the high order position. Again, it's 1 less because we don't want a high order 0. So what would that be? 8 times 7, 56. So if we can get a count of the valid numbers without condition and a count of the invalid numbers, we subtract the invalid from the valid, and that gives us the answer. So the valid numbers came out to be 90. In this case, 8 times 7 is 56. 90 minus 56 is 34. So that works. Now, there's just one other thing to think about here, and that is, actually, let me do a compile and run here. Case 1, case 2. Yes, this one, I just put this one in myself. So n equals 2. We've got the 3, we've got the 5, but let's say we also put a 0 in there. Now, the number of digits that we can use for everything except the high order digit is going to be 10 minus the number of items in the array, which is 3. So that's going to be 7. So the low order digit can have 7 choices. The high order digit can also have 7 choices. The reason being, we've already taken care of the leading 0. That's already in the array. So we don't have to subtract 1 for the digit count on the high order digit and say, well, we can't have leading zeros. We can't have a 0 in there at all because it's in the array. So that changes the count. Now the count is going to be 7 times 7, which is 49. The total number of possible combinations is still going to be 90. And 90 minus 7 times 7, 49. 90 minus 49 is 41. Okay, so let's take a quick look at the implementation here. We have a set, and for each number in the array, we'll go ahead and add it to the set. The total number of numbers that we can make with no restrictions is 10 to the power of n minus 1. Is every digit except the high order digit. We have 10 choices. For the high order digit, we have 9 choices. So 9 times 10 to the n minus 1 power. All right. And now to calculate the number of invalid digits, let's see, 10 minus the number of items in the set. Those are the numbers that we have to have. 10 minus that, that is going to work. Oh, yeah, now this is, we got to check and see if there's a 0 in the array. If there's a 0 in the array, then we don't have to subtract 1 for the high order digit because it's already in the array. We can't use it at all. If there's a 0 in there, then what we're calling K0 here will be K, otherwise K0 will be K minus 1. All right, then we take K, which is 10, minus the disallowed numbers, raise it to the power of n minus 1 for all the digits except the high order digit, and then K0 for the high order digit. Now, again, K0, if the array contains a 0, K0 is going to be the same as K. If the array does not contain 0, then K0 is going to be K minus 1. Multiply it out. That's the total number of invalid numbers that we can make. So we take the total number of numbers that we can make without condition, and we subtract the total number of invalid numbers that we can make. Okay. And let me scoot this over and we'll run it. All right. Let's see. Yeah, not much else to say about this one. Just some I don't know, combinatorics. I think the key insight is that it's not that easy to come up with a formula to compute this answer directly, but it is easy to come up with formulas to compute the total number of combinations without restriction, and it's also easy to come up with a formula to compute the total number of invalid numbers and then to just do a subtraction to get the final answer. So that's it. Like the video, subscribe. I'll send you a problem of the day in your inbox every day. And what else? Did I mention the subscription is free? And we'll see you next time.